So what's interesting about this is that here's one page inside of this big div, and that looks like it's going to be my home page, lectures, and over here, a syllabus link. But if I scroll down in the same file, notice now that there's another div whose role is also page, and its title is apparently lectures, and there's lecture 0 and 1. Scroll down further, here's the third page, yet still inside of the same HTML file. So in short, because I had the foresight in this example to know what the entire UI is, I can actually construct it all within one file, and then kind of link those several roles together by way of links that are not necessarily full paths. So this is obviously to a remote server at this URL. But notice up here, these are all relative. So HTML5 and specifically this library are leveraging fragment IDs, which normally jump you from one point in the page to another. So this isn't going to be some big hideous page that has stuff up here, then down there, as it would in the normal desktop web. It's actually going to be displayed a little more like mobile experiences we've had. And this thing here, this is just a skinning theme. I don't know why they chose A, B, C. The sort of worst example of like coming up with variable names, but A and B and C and D and so forth are all different skins that you can apply to this library. So let's go into the simulator and pull up this third example here and go into, let's say, framework and that single file. Uh-oh. I broke something. That's embarrassing. OK, let's go over here. So that it doesn't look totally horrific. Lectures 1. All right. So here's my new simulator. OK. I'll fix that during break or after class. OK, so actually, I'm actually kind of serious. Like, it's kind of annoying to test out your code for the next several weeks and just using a little simulator, or God forbid, your actual phone on 3G or even Wi-Fi. You can actually use a desktop browser and optionally fake your user agent string, if that matters to the server, which often it does not. Or you just resize the window, and you'll see in the first project spec, there's nice little Chrome extensions that let you click a button, and voila, Chrome is now resized to mimic a phone, as I did manually here. So now, notice I get a little nice hover effects, which is inapplicable when you're actually using your finger. But let me click this. And now we're getting the sliding effect. Right? I can click slides, and it's actually going to pull up the PDF, which would render then in the phone or the simulator in that case. And if I go back, it's pretty good about sliding. But feels like it just slid in the wrong direction. When I click back, I still see the address bar up top, and I would in the simulator. You can hide the address bar. Some sites do this, whereby if you pull up the mobile website, you don't see the address bar by default. And that's really because of a JavaScript hack, whereby if you're familiar with the notion of the scroll top property of a page, which says where should the scroll bar start, what a lot of websites do is they just, with JavaScript, say move the scroll bar 20 pixels, and there's your hidden address bar. But it's still actually there. Yeah?
Shouldn't that define an XML schema to pass validation, not rely on this data?
Say that once more?
Why doesn't that feature rely on a new XML schema to pass validation rather than relying on the data that attribute?
Well, OK, so why not use an XML schema or DTD to actually validate the HTML markup? The short of it is that browsers browsers only care about adherence, in theory, to a minimal set of standards. The data hyphen roles are meant to be unique to any old website. You could require that individual websites produce a DTD or schema or RelaxNG schema for their HTML. But I think the world just doesn't care enough to actually do that. I mean, I think that you could. You absolutely could. That would be a much more rigorous design. But I mean, we live in a world where they don't even require us to close some of our tags. And so that's kind of the mindset, I think, in general. Other questions? All right, so better, and if you're making a mobile website, and such as the one I demoed last week, the CS50 Fair mobile website, we did that little trick where we moved the scroll bar up so you didn't actually see the address bar by default. And it's better than having to roll all of those features yourself with CSS and JavaScript. So it's a way of getting started typically quite quickly. So the little tour there of frameworks. All right, so what about tools? So version control. So this is something we kind of sort of use in 50. In higher level classes, hopefully you've made more frequent use of this. And for this class, you will necessarily have to use version control. Specifically for standardization's sake, we'll use Git for the class, which alongside Mercurial and Subversion is kind of on its way out, are really among the top contenders these days. They're pretty much Git. Mercurial, Bazaar is another one. These are known as distributed version control systems, which are a leap beyond things like SVN, CVS, and older ones. Long story short, if you've ever used SVN or similar, these typically rely on a central repository. So you and your partner and your other colleagues all have local copies of some website or some program. And when you want to share that code or save that code for perpetuity to the central server, you quote unquote push it to or commit it to a remote server. The downside here is that as you're making local changes on your own laptop or desktop, if you're using something like SVN, you can push to the remote server, but you can't maintain versions in the same way in your local directory. So thus were born distributed version control systems like Git and Mercurial and others that allow you to not only commit your code, save different versions, differentials, as often as you would like in your own local directory. They also then let you push to a similarly designed central server, but you can also pull directly from your colleagues and such. So particularly in large organizations where it's not just you and a partner, it's you and 10 people, you and 500 people, you can actually share collaboratively and merge other people's code, source code files into your own work, give them your work, and so this is where things are going. So just to paint a picture of this, and we'll spend more time on this in labs, there's a few pieces of jargon that underlie most of these systems. If you think of this as a timeline going from top to bottom, on the right-hand side there we'll call the master branch. The master branch is the product that you care about. And every one of those little blue circles represents an interesting commit where you rolled out some feature and pushed it into the central server. But along the way, you might want to experiment, or different people might want to work on different things. And it's kind of a bad thing if everyone's working on the master branch, because if one person has a bug, commits that bug to that central branch, who does it affect? Absolutely everyone. So the idea of these systems is that you can quote unquote branch off of the main branch and have your own little branches depicted here as little yellow dots along this line that let you work on individual features and only merge back from left to right into the master branch when you have rigorously tested your code, it's been reviewed by some number of colleagues, and you're sure that you're not going to break the entire website. So companies like Facebook and others that are actually constantly pushing out changes to the website do engage in processes like this, where you work on your own branch, and you only are allowed to merge it into the master branch once you know it's not going to take down all of Facebook. That's at least the theory of it. But I'm sure all of you have tripped over bugs in Facebook and the like nonetheless. All right. If you really want to wrap your mind around this, gets sophisticated over time. And when there's more than just you and a friend, you can divvy things up, as this tutorial here has. We'll post this link online on the slides. But you can traverse a tree that is your source code repository. So what does this mean in real terms? Well, what it means, when you first sit down to do a project for the class, working with your partner, both of you, or well, at least one of you initially, will create an empty directory, maybe start writing some code, but the moment you're ready to share that code or commit it to some central server, you're going to run a command like git init for initialize this directory. What does that do? It stores an invisible directory called .git in your current directory that where a lot of metadata is stored. All of the differentials between files that you've saved. You can then add files to that repository. You can commit, which means save files to that repository. You can push files from your repository to a remote server. Conversely, you can clone the repository. In 50 this past year, some of you might have used the clone command to download lecture examples or pset distribution code. And you can also pull from another friend, which means don't make a copy of it. It means integrate everything into your own code. So for the course, there's a bunch of options out there. We've decided to use Bitbucket because, one, it's free, and two, because they give you unlimited private repositories. So you might, the biggest player out there is GitHub, which charges a fortune to actually have a non-trivial number of private repositories. Private just means only you and people you authorize can access your code. GitHub is meant to be more social, so if you've heard of this company, They're wonderfully popular, especially for open source projects, but by default, all of your code is open, which means when you push to the central server, it means the whole world can then pull or clone it themselves. Not ideal for a class, not ideal when you're collaborating on something of your own design. Bitbucket, though, is similarly free. It's because they want you to buy their non-free products, presumably, but they provide you with unlimited code repositories, so private repositories. So the first project spec will walk you through the process of setting this up, but what this is going to mean is both you and your partner will have one of these repositories. One of you will set up the project initially, and then you'll be able to collaborate with each other by way of committing code to the central server. The staff and in the future classmates can actually see your code and actually browse it on this website as well. They have nice little wiki and bug tracking features of it. So in short, we'll use a real world source code repository so that your experience is as real world as possible. Yeah?
Does that mean we have to use Bitbucket for all our collaboration?
For the course, yes. You can use, in theory, other repositories, but it's going to have to eventually get pushed into this, which is fine, because the whole idea behind Git is that you can actually push to multiple repositories if you would like.